Okay, so now let's look at how much of oil can be recovered from a well. As we said, even with our best techniques, only about half of the oil is extracted, and half is left underground. So again, oil and gas are trapped in porous rocks between impenetrable rocks. Uh, so and impenetrable layer of rock on top prevents the oil and gas from rising to the top. Usually water which is denser lies below the oil and natural gas. When a well is drilled, the initial underground pressure forces oil and gas up naturally, but that soon stops and then you have to start pumping it up. Then after that's done, you need more drastic measures to force up the oil. So the first thing you do is by injecting water into the reservoir, you are increasing pressure on the oil, and that leads to recovery of a little more oil. And less than a third of the oil can be is in the reservoir is taken out. So even after you pumped water, only a third of the oil is out yet. Okay. Now, so 65% is still left. And so what do you do? So now what you do is the next thing you would do is inject steam into the ground. The steam heats the oil and making it less viscous and allowing it to flow out more easily out of the rocks. So remember, all the rock oil was trapped in the rock. Um, in this picture, what? So in this picture, all this oil is easy to get. That's just floating oil, but most of the oil is trapped in the rock, in the porous rock, and that's what you're trying to get out. So, uh, so when you put steam and heat the oil, it flows out of the rock. Some polymers are also used to force the oil out of the reservoir rock, and you'd be concerned about some some of these chemicals getting into the groundwater. So the use of these enhanced techniques will increase oil production by 10 to 30%. So you go from about, anyway, a total of doing all this stuff, you're able to only extract 50% of the oil. Um, so so primary oil recovery, here are the numbers. About 10 to 15% flows under its own pressure. Uh, when you pump oil uh, and into the reservoir, an additional 25% is recovered. So let's say you recovered 10% initially, and then another 25%, 35% total, and then tertiarily oil includes steam injection and all that, and then you can recover another 15% for a total of 50%. Fracking is a process is often used to enhance natural gas recovery. Okay. And here's what fracking means. Water with chemicals is injected into the well under pressure to fracture the rock and allow gas to enter the gas well. So let me show you a picture. So by the way, here is the depth. This is 2,500 meters. That's 2.5 kilometers, about a mile and a half deep. Okay, so here's the well, and you pump water with chemicals under high pressure, and you cracked this rock. You fractured this rock, and then gas trapped in these rocks is released along the fractures, and this gas flows through the well. So initially you pumped water and chemicals under high pressure, and this water flowed out here through the openings in the pipes and crack the rocks, and then you wait, and then gas flows back up. So that's the idea. So you fracture the rock and allow gas to enter the well. This technique is controversial because of potential contamination of water supply with fracking liquids or natural gas. Fracking has been used in the US since the 1940s. Shale oil. Uh, Oil shale is sedimentary rock that contains complex hydrocarbons called kerogens. We talked about that. Heating kerogens breaks them down into petroleum-like material, and that can be used in place of traditional oil. So here is a rock containing shale oil, and if it contains enough oil, you can actually burn the rock. So rocks that contain substantive amount of oil can be burned. So you saw that organic matter is trapped in sedimentary rocks, and this turns into oil over millions of years. So some deposits are rich enough that the rocks will actually burn. Okay. In the U.S., most of the shale is found in the Green River Basin of the Rocky Mountains. About 600 billion barrels can be economically recovered. So here's how you do: you mine this rock. The shale is mined and crushed and heated to about 350 to 500 degrees Celsius to release the oil. In rich deposits, more than 30 gallons of oil can be extracted from a ton of shale. So here are the shale resources in the world. The world has a total of about 5,000 billion barrels. Okay, that's what that is. And you can see that the US has about 4,000 billion barrels. So, okay, so that's the total US supply. 600 billion barrels is in the Green River area. Okay, so the US has 80% of the shale oil in the world. Good quality oil shale produces an equivalent about 100 liters per ton of shale. Yeah. So this is about 12% of the energy content of bituminous coal, and bituminous coal is not even the best variety of coal. Okay, so in the world, Estonia is the only country where it gets most of its energy from shale oil. And you'll see that almost all of the pollution in Estonia is from the shale oil industry. Now in the US, we won't use the shale oil because despite the extensive resources in the US, there is virtually no extraction of shale oil because of the economics as well as our environmental costs. So we're not going to dig in the Rockies for shale oil. Okay, so this is where in the US, location of the US shale resources. It's mostly in Utah and Wyoming and places like that. So that's where the shale rock is. Uh, those are the bedded trona and halite, Green River Formation, and nacolite and halite. Anyway, so here are the problems with shale oil production. So you need water, lots of water to produce shale, and the area of the shale oil deposits have little rainfall, and water is a valuable resource. So you can't for agriculture, so you can't be using it for production of oil. And the spent shale, disposing that is a problem. Because of the lower energy density, large quantities of shale need to be processed. And so what are you going to do with all that crushed rock? So um, So, and there's other factors, so environmental consequences. So, like I said, 97% of Estonia's air pollution comes from the shale oil industry. People would be up in arms in the US if we did that. Shale oil production releases significant pollution and greenhouse gases. So, and the cost, some studies have suggested shale oil would cost about twice the price of conventional oil. Okay, let's pause.